Hi everyone, we are from Group 10. So I am Muhammad Afiq bin Hazli. My group members are Muhammad Anak, Thaqeef and Cosmartin. So today we will be doing our first assignment, assignment 1. So we'll be explaining question number 9, which is a Rod's Law question. So let's read the question first. So using Rod's Law, calculate and plot the XY data at total pressure. So this is the given data that is given, the vapor pressure for N-hexane and N-octane. It's the system that we're dealing with today. So the question asks us to plot XY data, plot the boiling point diagram, and what will be the relative amounts of liquid and vapor phase for a mixture containing 0.545 mole fraction of hexane at 100 degrees Celsius. So looking at this question, we have to firstly do another update this table by implementing Rod's Law. So firstly, I've done it beforehand, so I'll be explaining what I've done. So initially we know the N-hexane is more volatile than N-octane. So to make things easier, I've classified my pH as partial pressure of N-hexane and POS, partial pressure of N-octane, to make it easier to describe. So PVH is the vapor pressure, PVO is the vapor pressure for N-octane. So this is Rod's Law. So it states that pH equals to Px, X which is mole fraction of N-hexane in liquid phase, X times the vapor pressure of hexane. That is the partial pressure of N-hexane. So PO is the same thing, partial pressure of N-octane times the mole fraction. So since the total pressure is the partial pressure of both respective substances, so we can conclude it as the total pressure equals to the mole fraction of hexane times the vapor pressure of it, plus the since hexane is X, so octane will be 1 minus X, so the vapor pressure of octane times the mole fraction of octane. So from here we can find out the mole fraction of N-hexane in vapor phase. So this I profiled it as Y. So Y times total pressure equals to vapor pressure of N-hexane times the mole fraction of N-hexane in liquid phase. So now that we've listed down all the equation, we can proceed with our problem, which is our problem here is to find the values of X and Y so that we can plot the graph. So we can find the value of X by the given question. It already states that we already know the total pressure, which the question already gave us, which is 101.32 kilopascal. And it's already given us the vapor pressure for both respective substances, which is N-hexane and octane. So what's left is just substituting it. So we can just modify this equation to make it in terms of X. So this is we've done it here. So from here we can find Y, because Y we only need the vapor pressure of hexane and X, and total pressure which is already given. So we'll do an example, which is at 68.7. So we'll just substitute in the values, so we get 1. So since it's 1 means that the composition is only N-hexane in vapor and liquid phase in 68.7. So means this is the boiling point of N-hexane. So I'll do another example. So I did for N at 79.4, which is we just substitute in the values and we got 0.686, and for the mole fraction and vapor phase we got 0.929. So after I've done some calculation for the rest of the values, I've got this table. I've updated the table from the given question. So this is the table that I got. So from here, we can plot the graph for the XY data. So I plotted it. This is the graph that I got. So this is X, mole fraction and X in the liquid. This is Y in the vapor. So as you can see, the graph increases, the gradient of X increases linearly with Y. This is the graph I got. So at 1, they're both the same. Here is different because as you can see, the values are different. So it's 0.9 here. And you can see the differences here. I just based on the data that I've done. So after I've done this, so we have to plot the boiling point diagram. So I've plotted it here. So this is the boiling point for let me see. This is the boiling point of N-hexane. This is the boiling point of N-octane. So this is the just use substitute in the values here. So we got the profile, the diagram, boiling point diagram. This is to get the value of X and the value of Y. And then we can this is the answer for B. And for C, what will be the relative amounts of liquid and the vapor phase for mixture containing 0.545 mole of mole fraction of NX at 100 degrees. So for this question, we just have to find 100 degrees and then just line it up. So here, this would be our value for X, the lower part, which is the bubble point, and the top part will be the dew point, which is Y. So here is the Y. So for Y, I just line it down, and I got about 0.660, and X I got about 0.28. So that's my answer for C. Thank you.